Okay, well, so first thing, some of you who procrastinated noticed, Blackboard was having some issues on Friday night, right? So if you until like Saturday morning. So if you hadn't turned your Bible paper in before, I don't know, probably late afternoon Friday or something like that, you had issues submitting it. I know a couple of you emailed it to me. If you would just before like 4 o'clock today, go ahead and submit it onto Blackboard so I can conveniently grade it. I'm going to be grading them tonight. I won't mark it as late, so just do that for me so it's convenient, so I don't have to skim through my email and look for who emailed it and who didn't. Make sense?
Yeah.
All right. And then I'll put up the next Bible homework at sometime today as well, and that'll be due midnight on Friday as well. All right, so last time we're talking about assembly. When do we use it? When we need things to be really, really, really fast. We talked about two types of programming languages, domain-specific and general purpose. We've had a whole bunch of slides that kind of sound the same. They're looking at programming languages from different angles, okay, different lenses maybe. So domain-specific is a language designed for solving a very specific problem. I think I used the example of like a dishwasher or something like that. You know, if you're writing some software for the various cycles of a dishwasher, the dishwasher is not going to, run a video game. So it's a very specific tool, so the language is probably significantly simpler. General purpose languages are like the programming languages that we've probably heard of, and they're the ones that are built for solving large classifications of problems. You know, they're the ones that are writing operating systems and video games and Microsoft Word and all that jazz. Okay, so we talked about three kinds of programming languages. I kind of skimmed over functional. I said, don't worry about that right now. It doesn't really, it's an important type of language, but it doesn't really apply to us right now, and it would be difficult to explain, and you're not going to retain it anyways. So we did use the example of a telephone, where I kind of said here the procedural version of a telephone is a giant pile of wires sitting over here, where after a few minutes you're finally convinced it's a telephone, but most of us, when we think of a telephone, we don't think about something like that. We think about something that looks like a phone, and we appreciate there's a whole bunch of details inside of here, but we also know that we don't need to work with those details on a daily basis, right? That's where object-oriented programming comes in. Object-oriented programming says, hey, look, we recognize that that guy's a telephone. We also recognize that that pile of wires only has a couple of parts that the human, the person who's going to be using that tool, actually needs to interact with. So what we're going to do is we're going to give you a nice little bag or a Tupperware container, however you want to think about it, so you can shove all those wires in there, and it will allow you to poke holes in there, so only the parts of that you actually have to interface with become exposed. If you ever have to get to those wires, you can just take the lid off and get to the wires. But most of the time it's covered up so that you can kind of pass that phone around as a phone. Makes sense? As an object. So difference between procedural and object-oriented languages is actually fairly slight. It's an organizational tool. It's kind of evolved the way we've solved problems. As things got more complicated, we have to start giving ourselves some organizational structures to keep ourselves sane. That's what an object-oriented language does for us. Okay, so we didn't talk about this one yet, right? All right, so two types of programming languages. We have loosely typed and we have strongly typed. And these kind of go hand in hand. Up here, we talked about interpreted languages versus compiled languages. We said interpreted are relatively slow. Compiled languages are relatively fast. So these things kind of go hand in hand. If we come back down here, loosely typed languages tend to be relatively slow. They also tend to be interpreted languages. Strongly typed languages tend to be relatively fast, and they tend to be compiled languages. All right, so those guys they come with the job. Now, what does it mean to be loosely typed or strongly typed? So this ultimately has to do with how does memory work? In the language. So if we have a language that's loosely typed, when we create a chunk of memory, we create a variable, we need to remember something, we don't need to define the kind of value that lives inside of that memory location. All right, where in a strongly typed language, we do. So in the real life example, we go out to Target, we come home with a big Tupperware container, we put a sticker on it that says tax documents. And we shove our tax documents in there. And then all of a sudden the next year we decide, look, I'm broke and homeless, so I don't really need to pay taxes. So we're going to dump the tax documents out and probably store our shoes. Because when you're homeless, you collect shoes, right? It's just a thing. It's a problem-solving thing. All right. Now, no big deal. We don't need to go buy a new Tupperware container to hold shoes. This one's perfectly fine. We just take the tape off, put a new piece of tape on, say this guy's now for shoes, throw shoes in there. All right. So we have a multi-purpose container that can hold all sorts of stuff. But now we're going to say that this container is opaque. We can't see through it. All right. And we're also, just for the sake of this argument, we're going to glue down the lid, because we're that type of person. It's no longer convenient to peek inside. It's going to take some effort, right? Okay. So now in order to find out, you got 10 containers sitting in front of you, and one of them has your shoes in it. Okay. All the other ones have rattlesnakes. I thought this was just par for the course. Homeless people collect shoes and rattlesnakes, right? It's not. All right. So anyways, you got 10 containers. You don't know what's in them, right? You don't know what's in these containers. You're searching for something. You don't know which the containers has what you're searching in it. So what are you going to have to do? You're going to have to go through and you're going to have to peek inside of each one and take the little extra time to pry the lid off in order to kind of figure out what's in each of those containers, right? Rattlesnakes, you shake it and just see if something sounds like it's getting ticked off inside. I tell you the lizard story from Florida. So I had a condo in Florida. I usually go down to every winter until this last one I had to sell it. My wife, we've been down there a whole bunch of times. We go on a lot of cruises out of Florida. But this last summer was the first time we stayed there, or last winter was the first time we stayed down there for a long period of time, almost 2 months. And we had one of those, if you've been to Florida, they have the little tiny lizards, and one of them got into the house. She didn't like that at all. So she was all upset, and then next thing she created a phobia around these lizards. So I'm taking my aunt to the airport one morning, and my wife's all upset. She's venting to my aunt about the lizards when this cat-sized iguana runs across the road and the car in front of us hits it. Okay. So now she's even more traumatized. Before it was these little tiny lizards. Now she's convinced every lizard that's in the house. That's not including the tail. That's these gigantic lizards is what she's decided that we have all over the place. But yeah, it was pretty funny. In the middle of the story, perfect timing. And then here, to throw the Christian spin on this, and this is also a true story. The morning of the lizard death in the house, which was a traumatic morning. So I wake up, she's crying, and she doesn't know what's living in her bathroom, she said. And so I go on the death hunt, because I've been instructed to kill. All right. And this thing had climbed into this vent inside of the door, and I was able to take the vent out, and I actually got him alive. So I was going to throw him outside. I was a little tiny lizard then. She wanted it dead. And my wife is a very kind of pacifist, nice. Not in this moment. This was not one of her best moments. So she's standing there crying, holding I don't know, Raid ant spray or something. That's the only kind of poisonous spray she could have, on guard. And I'm I'm gonna throw it. No, you kill it. So I had to stab this thing in the head with a screwdriver. No, we're not done. Then I had to throw it out on the porch so that his friends see what happens when you come into this house. See, had I only watched Supernatural before this happened, I would have been more prepared for this type of situation. I would have used the holy water, the salt. Okay, we would have seen what was going on there. Because yeah. Now, so anyways, later on that morning, we drove down to the Florida Keys, and on the way down there, we passed this digital sign. They thought it was necessary to have this digital sign up that says "Beware of screwworms." Have you heard of screwworms before? Apparently they're making a comeback. It's like a flesh-eating bacteria that's found now in the Florida Keys. I don't know. I guess they dig into you, screw into your skin, and then they eat you, and then I guess they screw out or something. I don't know. Who knows? and I mentioned this is going to be the Christian worldview aspect of this, right? 45 seconds later, the right side of the road, probably a 6'3", 6'4", mostly naked dude carrying a cross. Just walking down the road carrying a cross. Like, well, I did. I'm going like 60 miles an hour, but and my wife's still crying. She looks at me. She said, "No, that's somebody who's being proactive about screwworms." So, two types of programming languages. How do we get from loosely typed? Oh, what types are the rattlesnakes? Then it's What's this?
You ever heard of
Komodo dragons? Yeah, very poisonous.
Yeah, they never take your wife there because she will probably have a heart.
Well, no, you just die. You don't have to worry about the heart attack. They eat you and everything. Just part of the whole ecosystem.
At least you're contributing.
Yeah, you're contributing to the. All right. So, anyways, the situation is this: if in a loosely typed language, we have a whole bunch of boxes, and we don't necessarily know what's in them because they weren't labeled. So we have to kind of peek inside and check what's in the boxes in order to get our data out, like before we get our data out. Okay. Now that's not that big of a deal, but certainly it's going to be slower, right? That we have to take the time to look. Where if we had engraved on the box what kind of thing is inside the box, it's going to be a lot quicker for us to find what we're looking for. Correct? And it kind of goes even farther than this. So let's look at, from a loosely typed language, we have something called a type inference engine. Okay, which is a really fancy name for basically a dude who checks the boxes before you're allowed to do something with it. So if you try to do math with something that's in the box that's not mathable, okay, so you got a string like the name Mike, and you try to add 7 to that. That doesn't make a whole lot of sense. Okay, so a type inference engine is going to check what's in the box first before it allows you to try to add 7 to whatever's in the box. Whereas a strongly typed language, because it has a type associated with the box, it knows whether that value is mathable or not to begin with. I'm not sure if that's a word, but if it's not, I invented it. It's a word now. All right, so we know what kind of value is in the box. Where this guy, we don't know until we check. And it's important that we say we have to check each time. Because it's possible when we deal with a variable, like we talked about a few minutes ago, I have a container that I put some stuff in. Nothing keeps us from taking that stuff out and putting new kinds of stuff in, right? Next time we go to use it, we got to check it again. All right, so again, these are relatively slow. These are relatively fast. Strongly typed languages also tend to be our compiled languages. Loosely typed languages tend to be our interpreted languages. Now, as we mentioned last time, computers are really fast. So most of the time, it's not going to matter whether we're dealing with a loosely typed or a strongly typed or a compiled or an interpreted language, because the computer's going to make them all feel fast to us. Right? So only on specific types of applications do we actually care. Sometimes it comes down to, in fact, as a computer scientist, most of the time, it comes down to which is the right tool for the job based on what's conveniently available to us, which of the thing has the right kind of libraries or functions associated with us that allows us to solve the problem we're trying to solve, regardless of how down to the, atomic speed, which one's faster. We care more about the power tool that allows us to solve the problem more conveniently for us than which one's going to give us the fastest speed under the hood that we may never actually notice. That makes sense? So in the big scheme of things here, don't necessarily consider loosely typed versus strongly typed as one of them being better or worse than the other. These are kind of just characteristics of our different kinds of programming languages. All right, and perhaps if you are writing a video game, and you're trying to pick the right tool for the job, based on our knowledge we're gaining here, you might start leaning towards your compiled, strongly typed languages just because they're relatively fast languages, and we've kind of decided that video games might be one of those applications that need to be fast. All right, we don't want to give up too much horsepower, even though we might not notice on something like Angry Birds. We will notice on something like Battlefield, okay, or pick your favorite game with a bunch of explosions and stuff like that. All right, so as we're selecting the right tool for the job, we're going to select the guy that's a little bit more of a power tool for us. Just like if you're cutting down a tree, you're probably not going to grab a steak knife. Okay, with enough time, you can get through a tree with a steak knife, right? But you're going to get one of those giant power saws, and after you cut a couple fingers off, and you go get somebody who knows what they're doing, and they'll finish using it. All right, so that's your two kinds of programming languages, loosely typed versus strongly typed. All right, so we started talking, well, at the high level, we started talking about the history of programming languages last time. And what I like to do, and this isn't necessarily the first programming language, but I like to base this chart off of the first language being a language called C. And it's not the first programming language. But for our purposes as the modern computer scientists, we're going to say it's the first language that matters, which may also be somewhat of a fictitious statement. Yeah?
On the C, same thing as C++.
It's not. Very similar, and it's going to make our chart here pretty quick. You're going to see it on our chart here in a second. In fact, here, because you asked the question, I'll give you the quick punchline. How about that? So here's C. This is already related to what we talked about. So I'll throw C right there. C is a procedural language. Big pile of wires, blah, blah, blah. As our computers started getting faster, as human beings decided, oh, I can solve harder and harder problems with our computers. Maybe we needed that next level of organization to hide those wires from us and make ourselves not go insane as we're solving problems. So C++ is the object-oriented version. It's object-oriented programming of C. All right, so while we're at it, why don't we go ahead and talk about this? Because I break this chart into a couple pieces. We're going to have our native languages over here, and then we're going to have our web-based languages over here. So I'm going to write something here. So we're going to call, here's the C programming language, and we want to think about what C gives us and then what the weaknesses of C are. So C supports variables. Remember last time I meant variables. There we go. Last time we reviewed that whole idea of how do human beings solve problems. We use our memory, we ask questions and repetition, and 100% of programming languages will have facilities for those three things. So usually memory is done through something called variables. Asking questions is done through something called conditionals or if statements. And the reason it's usually if statements is because most of our modern languages come from C. And C uses if statements for conditionals. All right, so we have variables. We have these things called arrays, which are collections of like types within a single variable name, where a variable in and of itself is a single name value pair. So I can have my first name is Mike. That's a variable. Okay. Or I can have a collection of, I don't know, I'm going to spend the next 5 minutes coming up with random numbers. And I'm going to store a collection of those numbers inside of some sort of list. And let's say I come up with 100 random numbers. I probably don't want to have a variable for every single one of those random numbers. I'd rather have a single variable called my random numbers and start filling it up with the numbers as I identify them. Make sense? So it gives me a collection of like type things. That's what an array is. All right. It also had something called a struct. So structs. Structs are a collection of name value pairs. So sort of kind of the best of both worlds, except you have to define it on a per name value pair basis. Don't worry about that. That's not really applicable to us. It's more just us comparing the languages here. So for instance, you could have a struct that for person, And maybe a person has a first name, that's a string. Has a last name, that's a string. Has an age, that's an integer. Something like that. Okay? So a bunch of name value pairs like that. Now, if you're writing an application, like maybe it's a scheduling application for a doctor's office, something like that, you're probably working with collections of people, collections of persons. So it might be handy for you to maybe be able to click a button and email a person. You know, have it send an email to a certain person, or send them a text message, whatever it is. Something related to that person. What structs do not allow, they don't allow embedded functions. So we cannot have a function associated with a struct. Therefore, what we have to have is this person here, this person object, where we store all the information about the person. And then over here, we have to have maybe a big collection of things that, almost like a puppet master, things that can manipulate people and do things relative to those people. That makes sense? So what we would do is we would maybe store the email address of the person with the struct. And then this function would take a person as a parameter and send a message to that person's email address, rather than us being able to tell a person to email themselves, something like that. Okay, so it's more about a convenience type thing. All right, so what we're going to do is we're going to say, what's the problem here? The problem with C. As the types of problems we were solving became more complex, the language started showing its weaknesses. And this kind of goes back to this example of us having the telephone that looks like the pile of wires versus a telephone that looks like a telephone. If the job of a programming language is to allow us to talk to a computer in as close to the same ways we already solve problems, when we think about a telephone, we don't think about a pile of wires. We think about a nice little telephone-looking thing that has the wires inside of it possibly, but we don't consider those, right? In the early days of programming, the problems we were solving were so trivial that didn't really become an issue, all right? But as computers got faster and as humans became better and better programmers, and those two started leading us down the path of solving harder and harder problems, all of a sudden we started noticing difficulties in working with those piles of wires as the programs got more complex. So we decided, we really need an upgrade to C. But we like a lot of stuff about C. In fact, a lot of C is still around in our languages today. So having said that, that's when they said, let's come out with an object-oriented version of C called C++. So I'm going to steal this guy. So this is C++. Still have variables, still have arrays, still have structs. But we added something called a class. And we're going to say a class is sort of like a struct that also allows embedded functions. And that sort of like a struct is an important thing that's going to come back here in a few minutes that we'll talk about. All right. So a class is how object-oriented languages provide their Tupperware containers. That's what it's called. They give you a container to stuff all those wires in. That container is called a class. Okay? Don't need to go any farther into it than right now. Go ahead.
Is a struct kind of like a dictionary in Python?
It is. And the correct word there is kind of, because structs actually work a little differently than dictionaries, but functionally, in terms of problem solving, they're the same. Name value pairs.
Right.
Yep. So what's different is how they're passed. If you pass a dictionary to another function, it's passed by address, where a struct is actually passed by value. We'll talk about that, but they don't act identically. Yeah.
Does it have to have name and value pairs, or is it a name or a value pair?
Name and value pairs. So, that's just the idea. So, my first name, Mike. So I have the name of the variable, the name of the memory location is first name, the value is Mike. Last name, name of the variable is last name, value is Littman. Name value pairs. Make sense?
Yeah.
So we've named what it stands for, and then here's the value associated with that guy. All right, so problem with C++. C++ empowered the programmer to make poor decisions. All right, so, we would say C++ is a pretty powerful language. And I'll even give a little highlight here because of direct memory access. The reason why C++ is somewhat dangerous is it allows you to directly manipulate memory. If you're an experienced programmer, this becomes handy that you can work with memory directly. If you're a beginning programmer and you're learning C, you're learning as your very first language, C or C++, you can work with memory directly, which means that you might overwrite part of your operating system in memory and require you to have to restart your computer in order for things to keep working again or start working again. All right, beginning programmers make a lot of mistakes. So not the friendliest language for that. And to give you an example, what I mean by empowers the programmer to make poor decisions. Let's say you're having a party at your house and you want to invite me to your party because we're best buds now, right? We're hunting together probably. Yep. Now, what would you do? Would you hand me your house and tell me to open the door at 8? Or would you give me the address where I can find your house? The address. I mean, you usually get one or two smart asses. Well, I'll give you the house, Maytag box, whatever. It's not that heavy. But generally, houses are heavy, right? They're big. So none of us are going to hand somebody else the house and tell them to open the door at 8. A language like C++ would allow the programmer to do that. Now, keep in mind, C++ is a much older language. This is probably a language from like the early 80s. 82, late 70s, something like that. C is kind of late 60s, 68, ballparky. So back then, memory was very expensive. So let's kind of talk about that for a second. Because this does really drive what's happened with programming languages. When we talk about memory costs. Famous guy. How many of you have heard of Bill Gates before? Who's Bill Gates? Just some dude? What company was he associated with? Microsoft. So he was the Microsoft founder guy. Okay, he one time had a quote that you'll never need more than 32 kilobytes of memory. Never need more than 32K of memory. Now, how much memory is in our computers today? 4 gigabytes? 8 gigabytes? None of you have a terabyte of RAM. You might have a terabyte of hard drive space. Right? We'll talk about the difference there at some point. Okay? So you go out today and you buy a new computer. A budget pleaser laptop probably has 4 gigabytes of RAM. Your common kind of run-of-the-mill decent computer has 8 gigabytes. A better machine probably ships with 16. If you're a gamer and you built your own rig, maybe you have 32 gigs of RAM in your machine, but that's really overkill. Anybody have more than that?
My dad has a 64.
64 gig? We got one of our seniors has a machine with 128 gigs of RAM.
Why?
His gaming rig is like a $20,000 machine. He's got liquid cooling. He's got 3 1080 Ti GTX 1080s. He's got the 36 core i9 Intel processor. I mean, just ridiculously overkill. And I think he uses it to like check his email or something like that. Yeah.
Do you recommend 16 gigabytes RAM or 32?
Well, I guess it depends. If you're buying a new machine today and the RAM is soldered to the board and you have the option to get 32, I'd get 32 because that future-proofs you. If you're buying a machine today that allows you to upgrade the RAM on your own, get 16. And when you need 32, go out to Newegg and for $100, buy more RAM and slap it in there and you're done. Yeah, but check to see how your machine is built. So like for instance, Macs. If you have a Mac today, max it. As much as you can, put everything into it as you can day one because everything inside this machine is soldered. There's no port to throw more RAM in it. There's no port to throw more hard drive space in it. One of the reasons why it's fairly fast for the hardware that's in there is because it's all just melted together with solder. There's no things plugging, no interfaces between things. But let's talk about memory cost a little bit, and let's kind of put it in perspective for us. So in 1996, how many of you were things in 1996?
What do you mean, like, weird?
How many of you were alive in 1996? Oh, we got like 1.5 people that were alive in 1996. Wow. You're like 1 or 2? You were 3? Okay. So in 1996, I bought a computer. I was a thing in 1996, and for a while before that too. So in 1996, I bought a computer that was a Intel 486 DX2 66 megahertz computer. We had to wait for the processor to be released. That's how bleeding edge this thing was. Keep in mind, your modern computers go up to like 3.2 gigahertz. And we're not even comparing apples to apples. We're basically talking about like somebody on a bicycle versus somebody on a spaceship. All right. But in any case, my machine shipped with a 420 megabyte hard drive and 8 megabytes of memory. Megabytes, not gigabytes. We talked a little bit ago about your standard computer today has 8 gigabytes of memory. How many megabytes in a gigabyte?
I never remember the comparison skills.
Conversions. Well, we have a bit. 1 bit is a single 0 or 1. One byte is 8 bits. One kilobyte, that's a big B, kilobyte, is 1,024 bytes. 1 megabyte is 1,024 kilobytes. 1 gigabyte is 1,024 megabytes. 1 terabyte is 1,024 gigabytes. All right, so if my machine had 8 megabytes in it, and a common laptop today comes with 8 gigabytes, that's 8 times 1,024, which is 8,192. Divided by 8, so well, we could have done the math pretty easily. Okay, so they have 1,024 times more RAM than my machine had. A lot more. Let's ask another question related to this. How many of you have internet at home? Most of us, right? What's the speed of your internet?
I don't know. I never know.
No, it's
One rule, first of all. If you're a technology major, you need to know what kind of technology you have at home. Make sense?
Yeah.
Okay. So, does anybody in here know what kind of speed internet they have? What do you have? I don't care. Both of you are going to get it wrong. Who?
16 gigabits, 16 megabits.
16
Yeah.
megabits? Okay, I'm okay with that answer. What?
I'm 60 down, 10 up.
60 what down?
Whatever.
The whatever doesn't count.
Yeah.
Get it.
No, I don't know what it is. I never did know that.
Well, you do now. What do you have?
60 megabytes per second.
60 megabytes per second? All right, so anybody else want to 50? 50 what? Okay, you're in the megabyte group. Okay. You said megabit group? Okay. Who's right?
Megabyte.
He's right. You didn't even get an answer. What do you have?
Megabits.
Megabits is right.
Yeah.
And a lot of the commercials, they say
Really?
meg. It's like, oh, you get a 100 meg download because they're operating off of. So, for instance, we had somebody who had what 64 mega. Well, you said megabyte, or actually we're slapping around gigabytes and megabytes and all this stuff, right? Okay, kind of a common speed today for like if you get the cheaper internet from like cable modems around here, you get 100 megabit. Okay. To see about how many bytes that is, that's 100 divided by 8. So your maximum theoretical download speed is 12.5 megabytes per second. Okay. Where the average consumer thinks they're getting 100 megabytes per second. But they sell it as a 100 megabit connection versus a 12.5 megabyte connection because they just use the word meg after that because your average consumer, and as we saw in here, your average techno person, doesn't know the difference, right? All right, so when you get 100 megabit per second internet connection, your theoretical maximum speed is 12.5 megabytes per second. What's the fastest consumer internet that really exists out there today that you can get at your house if you live in the right place?
Isn't it fiber optic?
Fiber optic isn't a speed. Fiber optics is a communication channel.
I know, but like, isn't that like?
It would be fiber based. What would be the speed?
About 1 gigabit.
1 gigabit. A couple companies offer 1 gigabit. Google offers 1 gigabit. AT&T offers 1 gigabit, and actually they offer 1 gigabit in downtown Milwaukee, and it's soon probably going to be in Mequon and kind of North Shore area. So 1 gigabit is 1,024 megabits divided by 8, so it's 128 megabytes per second maximum speed. But hold on. Well, now, okay, let's. How many of you watch a lot of like kind of older geek movies, techno movies? How many of you have ever heard of a T1 line? A T1 line. Okay, would you rather have a 300 megabit per second internet connection today or a dedicated T1 line to your house? Which would you rather have? So you rather have the T1 line?
I don't know what
Oh,
it
yeah,
is.
I
I
can't
can't
say
say
we
which
definitely
one.
want the T1 line.
So T1 lines, even today, probably still cost somewhere in the ballpark of $20,000, $25,000 a month. Where your 100 megabit or 300 megabit cable modem might be $100, $100 a month, 120 if you get the faster speed, whatever. The speed of a T1 line is about 1.44 megabit per second. Synchronous, both ways. Same speed up and down. Whereas as you were blathering on about stuff, you were mentioning something about your speed is faster down than up. So you have something like, what did you say, 60 gigabytes? Probably 60 megabit down by something like 5 megabit up or 8 megabit up or something like that. That way, because they don't want you running servers out of your house. You can pull information from an outside source down to your house more quickly than you could feed information back out. Because as a consumer, what are you using your upload for? Requesting google.com, for checking email, sending an email attachment, things like that. Not serving videos over BitTorrent.
Most of us won't notice the speed difference.
Well, that's actually a reasonable statement. Why wouldn't we notice the speed difference? How many of you think you would actually notice the difference between a gigabit per second connection and a 100 megabit per second connection?
Depends what you're downloading.
Okay, tell me about that.
Or if you're downloading like a big file off Google or something, you're gonna notice it downloads a lot faster. Or
Maybe off of Google. Because you can only download as fast as whoever's uploading it to you can give it to you. Right? So chances are whatever source you're downloading from isn't feeding it to you at a gigabit per second. Probably they're not even feeding it to you at 100 megabit per second unless they're one of the big providers like a Google or an Apple or Blizzard, Activision, something like that. Generally speaking, when you're downloading something, the most you'll ever see download speed, or let's just call it, you would call it a pretty reasonable download speed if you're getting a patch file for a video game at like 3 or 4 megabytes per second. You're pretty happy with that, right? Okay. Here on campus, you'd be happy with probably if it's even kind of touching 1 megabyte per second. In the mid 3, 4, 500 kilobytes per second, you're somewhat pleased here on campus.
I get 35 megabytes a second now.
You have gotten 35 megabytes per second down. You've also gotten 3 bytes per second down here on campus. Campus has nothing to do. I mean, we have a very large pipe up and down here, but you're at the mercy of sharing that with everybody else on campus. So you're going to get a significantly faster download speed at 3 in the morning or something like that than you would at, and this, I mean, it all just depends on what's going on and where you're downloading from, because we also have technology here on campus for throttling certain types of information. So for instance, if you're downloading some movie off BitTorrent, probably a completely legal documentary, I'm assuming, you're probably going to get that throttled, slowed down during at least waking hours, because other people need to be able to use the internet for like legitimate stuff. Go ahead.
So is that where bandwidth comes in?
Well, that's what bandwidth is.
Sharing thing?
Sharing has to do more with the underlying technology. Here on campus, we use Ethernet, which is a bus-based sharing technology. You'll learn all about that like in a networking class. But at the end of the day, from our perspective in here, what's the most important is whatever you're downloading from, whoever you're downloading from you're only going to download as fast as they can feed it to you. Make sense? And most sources out there are not going to feed information to you much more than 3, 4, 5, 10 megabits per second. So now we're talking about something like in the 0.7 to 2 megabytes per second. Yet you're getting these, if you get gigabit internet, you can get 128 megabytes per second. Is it overkill? Just to brag your neighbor, I have gigabit. Well, I mean, he's already telling people he's got gigabyte. Doesn't even matter. But why do we need these faster internet connections? Yeah, but I already told you that if you're downloading from one source, probably 90% of your internet connection is not even being used, because you're only downloading as fast as they can give it to you.
Yeah, but most people don't know that. So
Fine, most people don't know this. It's just all a big ripoff.
kind of, they like something.
So let's take your average house. How many sources are you downloading stuff on the internet from at a single point in time?
Like I've got 3 or 4, probably like 3.
So you got a couple of cell phones checking their email. You might have 1 or 2 people who are downloading crap off of Netflix. Shut up! I always hit somebody with that early on. So what were you babbling about? All right, so maybe you have 1 or 2 people downloading from Netflix. So that's taking up some speed. Okay, maybe you have somebody downloading he's got 5 or 6 streams on BitTorrent going at once, right? All those things add up, because you're downloading for a whole bunch of different sources. So this guy's giving you 2 megabytes per second. This guy's giving you 1. This guy's giving you 0.4. And it starts adding up. So now you have the total bandwidth to be able to pull stuff at from lots of different sources at a reasonable speed. And that's where you might end up running out of bandwidth from a slower internet connection if you're sharing stuff with a lot of different people. That makes sense? So over here on this side, when we go from bit, we have 1 kilobit, small b, that's 1,024 bits. 1 megabit, this is a small b, this is 1,024 kilobits. 1 gigabit is 1,024 megabits. And then 1 terabit, which nobody really talks about, is 1,024 gigabits. All right, so when we talk about memory cost here, and I'll spin back around on this next time, but in 1996, I bought an 8 megabyte RAM chip. Now today, so we'll say 2018, if you buy a 4 gigabyte RAM chip, how much would that cost? $30? Something like that? So that's $30 today. So if you do the math on that, that's 4 gigabytes times 1,024. That's megabytes. That's 4096. So we're going to take 30 divided by 4096 is going to give us 0.007 dollars per megabyte times 100. That gives us cents. Less than a cent per megabyte. So that should give that. So that means that times 8, my RAM in 1996 should have cost me less than 6 cents. How much do you think I paid for that 8 megabyte chip in 1996?
Yeah. Over $100.
You think $100?
Over
Too much.
Oh, what?
Are you serious?
Paid $1,000 for it. Okay, we'll pick up next time. That number was after RAM had already come down in price a bunch.
What? What was it before?
More. Less for more. All right, I'll get the next Bible homework up this afternoon. Make sure if you did not already submit your Bible homework on Friday because the blackboard was down, get it submitted today before 4 o'clock so I can grade it tonight.